Okay, welcome back. So now we're going to look at solving logarithm equations. So this time what you'll see is that you're being presented with a logarithm and you have to somehow get yourself out of that log, which guess what? You're going to use exponentials because logarithms and exponentials are inverses. Okay, so what do I mean? Let's go back to our document and see how this one plays out. Okay, so back on our document, second half now, part A, solve this equation. So check it out, part A, the log base 3 of 4x minus 7 equals 2. Your job is to solve it. Okay, well, if you are tempted at all to add 7 right now as your first step, wrong. Don't do it. No, incorrect. Completely incorrect. Do not add 7. Why can you not add 7? The reason you cannot add 7, ladies and gents, is because 4x minus 7 is part of this whole thing in the logarithmic statement. That quantity is not just any old quantity that you can, algebraically manipulate. No, that thing inside of the log represents the answer of the exponential that you're trying to accomplish. So you cannot just start haphazardly moving stuff around necessarily if it's a logarithmic equation. So go back to part A with me. Bases, powers, and results. When you look at that logarithm statement, what do you see? What is the base of that log? 3. What is the exponent in that logarithmic statement? The exponent is the thing out here. So the 2 is the exponent. Okay, and what's the result in the logarithmic statement? It's that thing in parentheses. So the 4x minus 7 is the result. Okay, listen to what we just said. The base is 3, the exponent is 2, and the result we're trying to make is 4x minus 7. Do you realize what we just said? We just said an exponential statement, ladies and gentlemen. The base is 3, the power is 2, and the result we are trying to make is 4x minus 7. What we just did is we interpreted the logarithm in its inverse form. Exponential is the inverse form of a log. And it turns out that as soon as you acknowledge the inverse form, you're like, oh, wait a second, I can solve that. I know what 3 squared is. 3 squared is 9. And wait a second, now that I know that 3 squared is 9, I can just keep going. Sorry, I have the sniffles. Bear with me here. That's it. The answer is 4. Done. Moving on. I know, she makes it sound so easy, right? When you see a logarithm, ladies and gents, all you have to ask yourself is, okay, but what is going on in this logarithm? Who's my base? Who's my power? Who's my result? And if all the components are there, well, then you're ready to interpret it and you're ready to move on with the algebra that ensues after acknowledging the inverse form. If we were in person right now, I would be asking us this little series of questions, and it gets really annoying and students are like, really, Bishop, we're doing this again? And I would say, yes, we're doing this again. And here's what I would say. I would say, hey class, what is the inverse of addition? And you would all be like, subtraction. And then I would say, hey class, what's the inverse of multiplication? And you'd be like, division. And then I would say, hey class, what's the inverse of squaring? And you'd be like, square rooting. And then eventually I would say, hey class, what's the inverse of an exponential? And you would say, logarithm. And then just to be obnoxious, I would do it again, and it would sound like this. Hey class, what is the inverse of subtraction? And you would say addition. And then I would say, hey class, what is the inverse of division? And you would say multiplication. And I would say, hey class, what's the inverse of a logarithm? And you would say an exponential. So think about it. When you see an addition problem in a formula or in an equation, you subtract it. That's how you undo the addition, is you subtract it. When you see multiplication in the equation, you divide, because you know that that's going to undo that step. Well, ladies and gents, when you see a logarithm on paper, you need an exponential to undo that. The inverse of a logarithm is an exponential. As soon as you know who your base, power, and result are, you're ready. Go, invert it. And then you'll notice that the problem will progress after you acknowledge the inverse. Now, do be careful though, because look at part B. When I look at part B, I see a lot of extra stuff. I'm like, okay, I see a logarithm. It's definitely base 5. The result, you know, that thing in parentheses, is x plus 1. And the exponent, I'm thinking, is 3. But then again, what's up with the plus 6? And what's up with the negative 2 sitting out in front? There's a lot of things that I did not mention. There's a lot of extraneous stuff on this equation. And so what that tells you, similar to the top half of this activity, is that it's just not ready to be interpreted yet. So the first thing we have to do is get rid of that extraneous stuff using typical inverse operations. So addition by 6, I'm going to subtract. So negative 2 log base 5 of x plus 1 is 3 minus 6 is negative 3. Okay, base 5, result x plus 1, power negative 3. But what's up with the negative 2? Yeah, I don't know about him. Negative 2 feels like it's neither a base nor a power nor a result. So what do I do with it? Well, you get rid of it. So just because you can, you divide the negative 2 off. So now, log base 5 of x plus 1 equals 3 halves, or 1.5 if you must. Okay, so now I'm looking at it and I'm like, okay, base 5, the exponent is 3 halves, the result is x plus 1. Now what? Can I subtract 1? No, because that's part of the logarithm, that's part of the result. Okay, well, if I can't subtract 1, then what do I do? I feel stuck. This is when a student would call me over. Bishop, I feel stuck. Yeah, you feel stuck because you've done everything you know how to do. You've exhausted all of the inverse operations that have been comfortable to you. Well, what you need is to add an inverse operation to your repertoire toolbox and realize the reason you're stuck is because it is time to invert that relationship and write it in its other life form. Who's the base of this log? 5. Who's the exponent in this situation? 3 halves. What's the result I'm trying to make? X plus 1. There you go. You have interpreted the log. So now that you've interpreted the log, guys, check it out. 5 to the 3 halves. I can do that. Grab a calculator. What's 5 to the 3 halves? I don't know. 5 to the 3 halves is 11.18. Okay, 11.18. 11.18. Cool. X plus 1. Oh, wait, not done yet. The final answer is 10.18. Ta-da. Okay, so excuse me. Are you catching on to the way that these progress? You always, whether it's exponential or log, doesn't matter. You always want to first just kind of ask yourself, like, what do I have? Who are my bases, powers, and results? And once you acknowledge who your basis, powers, and results are, you can then assess whether or not there's any extraneous other stuff that might need to get moved before you can invert it. Because again, ladies and gents, the inverse relationship is bare bones. Look at that relationship, bare bones, base, power, result. That's it. There's no plus blankety blank or times blankety blank in that notation at the top of the page. No, bare bones, basis, powers, and results. That's it. So if you have anything else other than basis, powers, and results, get rid of it first. Then interpret it either from exponential into log or from log into exponential. But either way, the inversion piece eventually has to kick in. So then last but not least on part C, notice it's ln. See how it says ln right there? So as we kind of alluded to and talked about earlier, it's also in the PowerPoint from last week. Natural log ln is base e. Even if it doesn't say e, you just have to know as the mathematical reader in the room that ln is base e, period. So if I were looking at part C, this is what I see. I see that it's a base e. I'm thinking the exponent might be 4 because the thing on the equal to is always the exponent. And I'm thinking the result is just x. Okay, but notice I didn't mention the 5. Notice I didn't mention the 2. So extraneous stuff. Do you feel that? It's extraneous. So what do you do with it? Well, you get rid of it first. That means you don't put it into exponential form yet. First, get rid of the extraneous stuff using typical inverse operations. Get rid of the 5. So 2 natural log x is actually -1. Get rid of the 2. So the natural log, oops. Undo? No? Back. Whoa. Really? Oh, there we go. So the natural log of x is -1/2 or -0.5. And so now you're looking at, okay, I've subtracted 5, I've divided by 2. Now what? Am I done? No, you're not done. You might feel stuck. And guess what? That's usually a good sign. It means that you've exhausted all of your comfortable algebra. And what you have is that it is time to interpret the inverse operation. Natural log of x equals -1/2. So solve for x. Well, what does this mean? What's the base? E. What's the exponent? -1/2. What result are we trying to make? Well, x. So listen to what we just said. The base was e, the exponent was -1/2, and the result we're trying to get is x. E to the -1/2 equals x. That is totally computable. Go to a calculator, e to the -1/2, type it in, done. After you interpret that log, that is what gets x out, so to speak, and no longer in its input logarithmic form, but as its output of the exponential. So whatever e to the -1/2 is, that's our answer. So I'm going to go over to Desmos. I need e to the -1/2. 0.607 if I round it. 607. Remember, e is just a number. It's 2.718285 something something. But it's just a number. It's 2. Yeah. What am I doing? Oh yeah, 0.607. 0.607. 0.607. There we go. And that's it. You've officially solved that logarithm equation. Okay, so as one last kind of like takeaway message, if you will, when you are solving these, once again, it all comes down to the inverse relationship, but most importantly, it's knowing which piece means what. So if you have an exponential, then in its most basic form, you would have a base being raised to some power to make some result. That's essentially what b to the x equals y is trying to say. You have a base, a power, and a result. And in exponential form, the base lives here, the power lives up there, and the result lives on the other side of the equal to sign. But in logarithmic form, you have all the same three components, but they live in different places. You have log, that represents the log, obviously. The base is down here, written as a little subscript. What's inside of the log is the result the exponential desires to have. And the answer to a logarithm is the power that makes that happen. So in logarithmic form, it would be log base b of y equals x. But that right there is where the three elements live, so to speak. And you need to be able to acknowledge those three elements when you write these in their alternate life form, because again, this is an inverse relationship. So from this point on, if you're trying to solve an exponential and you're like, well, how the heck do I solve an exponential? Simple, you use a logarithm. That's how you solve an exponential. You use a logarithm. Logs are the inverse of exponential. And similarly, if you already have a logarithm, like here, have a log, and you're like, well, how the heck do I solve a log? Simple, you use an exponential. So you'll always have to acknowledge, what do I have in front of me? Is it an exponential or is it a log? And then what would it look like in its other format? Making that leap is what it takes to solve these. But once again, you can't make that leap until you've got it down to bare bones basis, powers, and results. So hopefully that is helpful. This is definitely one of those lessons where you're going to have to practice. If you have been trying to skimp by and not doing the homework or whatever, yeah, that's not going to work on this section. You really have to practice it. It takes time. Let yourself make mistakes and try to learn from those mistakes, obviously. And if you need me, you know where to find me. We can hop on a Zoom call. We, of course, have our tutoring center that's available. You just click on tutoring center in Canvas and poof, you're connected with a human that works for us here at CGC. So hopefully it's making some sense. And once again, I personally love logs. I used to hate them back when I didn't understand them when I was a student, a kid. But once I got the hang of it, I just think they're so neat. I love having that inverse operation in my toolbox. And by inverse operation, again, I mean logarithm. Logs are just inverses. And they're actually really, really useful in the fields of science and engineering. People use logarithms a lot. So in the actual field is what I mean. So hopefully you find it meaningful and hopefully they make sense. That's what's important to me. I want them to make sense. So thank you for your time and have fun.